Hello, everyone. My name is Maya, and I will be your host for today. Welcome, and thank you for taking part in this MDPI's webinar entitled New Milestones in Drones, from new drones designs to real-time and artificial intelligence applications. This is the third webinar in the EO and GEO series, organized by 4 MDPI journals: Drones, Remote Sensing, International Journal of Geoinformation, and Land. If you're interested in contributing to this topic, don't hesitate to submit your research to the relevant topic, Advances in Earth Observation and Geosciences, and relevant special issues, and I will post more detail about them in the chat box later. Before we start, I would like to briefly introduce you to MDPI. MDPI is a pioneer in scholarly open access publishing and supported academic communities since 1996, and currently we have 422 diverse and open access journals, and working with more than 115,000 academic experts to provide high quality service to our authors. I would like to remind everyone that today's webinar is being recorded, and the recording will be made available online as soon as possible. So today we have 3 presentations of 20 minutes each. After each presentation, there will be Q&A time moderated by the chair. And if you have any questions for our speakers, please post them in the Q&A box at the bottom of the screen. And please remember to mention the name of the person to whom are you addressing your question. So our chairs for today are Professor Diego González-Aguilera and Dr. Pablo Rodríguez-Gonzálvez, and I will read their short bio. Diego González-Aguilera is a full professor and head of the Geotechnologies Master's and PhD program at the University of Salamanca. He was the research assistant at RINIA in Grenoble, France, in the Institute of Computer Vision and Robotics, where he also performed his PhD research on 3D reconstruction from a single view. And based on his PhD results, he has received 9 international awards. He has authored over 370 research articles. He's a co-inventor of 11 patents and 32 intellectual properties, co-founder and CEO of a startup Image to Smart 3D, and also he's the editor-in-chief of Drones Journal. And Pablo Rodríguez-Gonzálvez is associate professor in the Department of Mining Technology, Topography and Structures, and coordinator of the Dracones Research Group at University of León. He has authored over 120 research articles. He holds 10 national patents and 20 intellectual properties, and he is the co-editor-in-chief of Drones Journal. So thank you both for chairing today's webinar. That is it from me. I now hand over the microphone to our chairs, and I hope you all enjoy.
So thank you so much, Maya, for the introduction, for the presentation. So first of all, I would like to say thank you for organizing this fantastic event, and especially thank you for the speakers, okay? That it's a privilege to have this expertise today on board regarding the different disciplines, the different backgrounds they are coming, and for sure that is going to be a successful webinar. So only a few words about the Drones Journal. That this is the journal that is organizing this event. First of all, as you know, Drones Journal is indexed in the best database of scientific community. So the impact factor up to now is 5.5 in journal citation report and 7.2 in Scopus. So thank you to all these members, especially editorial board members that take part during this journey to get this successful number, okay? So it is important also to highlight the 3 main pillars of Drones Journal. The first one is the design. So all the papers related with the design of unmanned aerial vehicles or whatever type of unmanned vehicle are welcome to be accepted as papers. But also it is important to highlight the pillars related with the development and applications. It is important also to note about the timeline of Drones Journal. If you can have a look, we founded this journal together with MDPI in 2017, and in more than 5 years we get success indexing the journal in Scopus at first, and then in journal citation report. Okay, so again, we believe that we are in the right way to get the best milestones related with drones using this great channel that MDPI is offering to the scientific community. This is a clear picture of the number of submissions that Drones Journal received in the last year. If you have a look, in the last year, we get close to 1,000 papers with a rejection rate around the 50%. So it is important to highlight the increase in the number of papers in this last year. And for sure, it is important also to highlight the quality assessment that from the editorial board, led by the editor-in-chief, we are trying to push. We create these guidelines and tips for the academic editors in those journals in order to assess with the best quality and the best rule the papers that are submitted to Drones Journal. Especially, we have to take into account that nowadays we are living in, let's say, artificial intelligence world. So it is important to put the best tools in order to assess the quality of the manuscript submit and try to provide tips to editors in order to reject those manuscripts that can be created, let's say, in an artificial way. And to this end, we create, together with MDPI, these guidelines and tips for this academic editor. So it is something very important to highlight. Also, a clear picture about the different countries that are taking part in drones. And for sure, it is important to highlight the number of different countries. In the last year, we get 73 different countries which submit papers to drones. So I think that it's an important milestone considering the last numbers of the last year. So it's important to reinforce this, let's say, universality of the papers submitted to drones. And last but not least, I would like to highlight also the important effort that we are creating from the section development. So we create different sections that are focusing specific topics from drone design and development, passing through drone communication to drone ecology and drone in agriculture and forestry. And in this last year, thanks to our co-editor-in-chief, we create a new section development focused on innovative urban mobility, led by our co-editor-in-chief, Pablo Rodríguez-Gonzálvez. So it's for sure to be a successful sections, considering that is a, a hot topic today in the scientific community. Okay, and now I would like to start with the presentation of our speakers, starting from the first one, that is Professor Francesco Nex. Professor Francesco Nex is adjunct professor at the University of Twente. Francesco Nex received his master's degree in environmental engineering in 2006 and his PhD degree in geomatics in 2010 from the Technical University of Turin in Italy. From 2011 to 2015, he was with the 3DON unit in the Brusno Kessler Foundation in Italy as a researcher. His research focused on the development of innovative solutions fusing elements from photogrammetric computer vision, deep learning, and adjacent domains, such as robotics, to promote the development of innovative remote sensing solutions. Francesco Nex is author of over 160 publications in international journals and conferences. Since 2019, he is the 2% most cited scientists ranking published by Elsevier every year. He is chair of drones of the ISPRS and head of the UAV at Twente University. In 2020, Francesco Nex was awarded with the ISPRS President's Honorary Citation and with the Thomson Award. and since 2023, he's also research associate in the CNR. So this is all from my side. Thank you for coming, and thank you in this case to Francesco for presenting his talk.
Thank you for this kind introduction. Thank you again for this introduction, Diego. Today I will try to give a short overview on the potential of the use of UAV mapping in real-time applications. It will be quite a quick overview of what is possible to do. So we will first of all discuss why we use UAV at the moment and why we want to use them in real time for real-time application. I will show some of the example of our research group in some ongoing and past project, showing some solution that we develop, and I will briefly sketch what will happen, what is next in this kind of process. So first of all, why UAV? And then it's quite easy. I mean, I think it's an answer that more or less all of us know. UAV have compared to other typologies of data acquisition, have a higher resolution. They are low cost and flexible, so they allow to acquire data in a very low cost way and a flexible way. And they are particularly useful when we have some repeated acquisition to do in order to monitor some processes or some areas that are under development. And last but not least, they don't need, compared to other typologies of data acquisition, external data provider, like it happened for airborne or satellite data acquisitions. If we look around in the literature of all the paper that are published on the different journal of the geomatics remote sensing domain, we can see that are basically two main stream of publication on UAV at the moment. There are the ones that are, let me say, a little bit more related to photogrammetry, that are working with the such an example, the registration of UAV data with different typologies of data that can be different resolution, like in this case, between UAV images and airborne images, or can be the registration of different typologies of bands, so data that are acquired at different bands. Then there are other typologies of papers that deal with data acquisition, so how to generate a complete 3D model, how to plan the flight in an accurate way. And then another big topic in this photogrammetry field is related to the georeferencing. So how to get accurate reconstruction, accurate and very well localized, or still how to use direct georeferencing, so all the instruments that can be installed on board of a drone in order to get some accurate position of the drone itself during the flight. Beside this, there is the more remote sensing research line that is at the moment related to AI in general, so to the use of artificial intelligence algorithm for detection, any kind of detection that can be for damage building, can be for object, cars. We will see some example later. Then there is the big other topic that is on the segmentation. So when we have to segment, to divide our area in different parts, in different areas of interest. And of course, a lot of work on the classification, that can be the classification from RGB images or for multi and hyperspectral data. These are the two main typologies of research that are at the moment ongoing with drones. Of course, this is not a complete overview, but let me tell that in a way, this is how things are mainly going. But of course, all these kind of papers are somehow also dealing with topics that are already available in the commercial solution. So both for photogrammetry and for remote sensing, we have some very good commercial solutions that are already able to give similar results. And they always use the, let's say, old-fashioned way to proceed. So they deal with applications that are typical in post-processing. So we acquire the data on the field, we go home, we process the data, and then we deliver the results. So in a way, this is an acquisition that basically can take, or a process that can take several days before giving an output. But if we look around, there are quite a number of applications where we need for real-time information, such an example for infrastructure monitor, for surveillance, for search and rescue, or still for precision agriculture. These are just some of the example where this is important. And of course, we have on in our support better communication compared to few years ago, a better miniaturization of the different sensors and processing unit, and many other kind of infrastructure related to Internet of things that can help in order to make this kind of solution more affordable and reliable. So this is a little bit where we are going as a research group. We are trying to develop application that can be summarized a little bit in this slide. So we have on one end, on the left side of the slide, the drone itself that acquired the data, and then basically two streams of processing that are going in as much as we can in real time on the 3D reconstruction of the environment with a 3D map, and on the other end on the semantic analysis, so on the understanding on what we see in the scene. So 3D map, scene understanding, so detection of object, classification, segmentation processes that are then fused into a 3D semantic map. That is the final product of our processing. Of course, our solution vary and depends a little bit on the different typologies of project that we have. So we have processing that can be performed on the edge or can be done in remote. We can use customized, we will see, or off-the-shelf drones. And of course, we can deal with indoor or outdoor application. And the final output, again, depends on the application that we are considering, can be a simple 2D map or a 3D model. So I will give you just an overview of a few projects. The first two are, the first 2 points are on the 3D mapping for outdoor scene understanding and scene monitoring, while at the end of this presentation, I will focus more on indoor mapping, specifically for search and rescue application. But again, in all these three typologies of project that I will show you, there are always these three elements. So the real-time processing, the geometric reconstruction of the space that we are investigating and are surveying, and the classification or the object detection, so a semantic understanding of the scene. So for the outdoor 3D mapping, basically the main idea that we had in the Auver and the Inacus project that are already completed project was basically to have the 3D mapping of an interest area with a replicable solution. So we didn't go for something that was a customized drone, but we said, okay, let's start from a drone that is commercially available, and let's try to modify this drone in order to give a solution that can be easily replicable in multiple exemplars, no? And that can be extended or used by a large number of people. So what we did basically was to develop an app that is able to communicate or allows the communication between the drone and the PC. And basically this communication allowed them to do the processing on the PC, on the field. So what we did was a nice, or now is better, Windows interface on the laptop, and then to have a small app on the smartphone that is connected to the remote control in order to stream this information and to be able to process this information in one go on the field. And basically what we get is what you see. So this is basically, this is the drone that you can see here that is flying, and on the fly with some SLAM, some framework that comes from computer vision and the robotics field. We were able basically to reconstruct in 3D. You see here the depth map, the area that you are flying and you are surveying in real time, and to mosaic and to generate a sort of a quick orthophoto of the area. And here you see that this is happening basically on the flight during the data acquisition. So what do you do with this? Now you generate this map. Of course, the orthophoto is not so good or so detailed as you could do in post-processing. But in this specific case, this was a project that we have with the National Police in the Netherlands. What we needed to do was to detect the position of the cars in the area on the flight, and to replan always on the flight a second flight in order to acquire the number plate of the cars. So this is an example, such an example of my old car, where you can see that we were able basically to replan the flight, position the drone in order to see the back or the rear or the front of the car, acquire a second image, and from a sequence of other AI algorithm to extract the number plate of the car, and to share this information with the ground in real time. In the same setting, in the Inacus project, was used for something that was related to search and rescue. So in this case, what we did was on the orthophoto detect the areas where some debris was visible in the images, and then to basically to generate in real time a map that was uploaded on Google Earth with the position of the debris in order to guide the first responders in their acquisition or in their activities during the first hour after an earthquake. So in this way, they were able to understand where there were some destroyed buildings, and to prioritize their activities in these areas. A second project, always on outdoor scene monitoring, was the Panoptis one, where in this case we said, okay, let's try to do something on a different drone. So it's something that is not off the shelf, but this is something that is basically customized. So in this case, this hybrid drone, vertical takeoff and landing, had some onboard unit. In that case was a Xavier Nex onboard unit, able to do the processing online, using the camera that was on board, and to stream only on the ground with a 4G connection the relevant information. This kind of process was done in order to monitor some highways in different countries. This was a European project. So what we did was to get some simple assumption. We don't know exactly the geometry on the ground, but we know the fly height, we know what is the angle of the drone, we have the telemetry of the drone, and then in this way you can infer, such an example, the speed of the object that you are capturing. So we are in the Netherlands, we don't have so many cars, and we started our test with the bikes. So we had some students going on with their speed control on their bike, and we did several tests in order to see if these first assumptions were valid. And then we further tested this assumption using some other data set that were coming from other places. And in the end, the system worked. So we were able, combining the telemetry of the drone and combining basically the information that comes from the images to detect the speed of the cars and to have this information. Other than this, we also developed some algorithm for real-time semantic segmentation in order to combine this information together and to get basically the speed of the car, so the object tracking basically, with some semantic information. So the final results was basically the possibility to track in real time the car speed on the lane, so to know how the cars are going, so if they are going fast or not, and not only, but thanks to the semantic part, also to detect possible obstacles that are visible on the lane, and then to spot this kind of information on the ground also in real time. Moving to the indoor, again, we work quite a lot as a research group in the search and rescue. So what we were asked to do was to basically to generate some information for indoor mapping. So we started already a few years ago with a different solution. The first one was on using the Tello drone, and again, streaming this information, this data on the ground. And as you can see, basically, the Tello drone acquires the images, stream the data in an easy way on a laptop, and we are able basically to build and to reconstruct the scene in 3D. The next step was to use a crazy fly, and in this case, the crazy fly uses some lasers, so not images, but laser. And also in that case, basically the idea was to have basically the main geometry of our environment, and to give a sort of information to the first responder who are outside the building of the volumes of the building where the drones are entering. And again, these are solutions that are relatively cheap and then can deliver in a quite effective way, at least some main volumes of of the area that we are surveying. I was before surprised. I didn't remember that Diego had a background on single image depth estimation. Single image depth estimation is now really progressing a lot with deep learning, and basically this is what we did also. So we are using nowadays a single image depth estimation algorithm that allow from a single image to detect and reconstruct in 3D a scene. And yeah, this is an example of what you can get over a sequence of images in an outdoor scenario. So it's a quite famous data set that is given by the computer vision community. So our algorithm is able to run in real time on a small onboard unit, and this is what you can get in an outdoor solution. So what we recently did, and we are still working on that, is basically to use this kind of information combined with semantic segmentation in order to have some real-time 3D scene graph using basically a simple monocular camera and the IMU that is embedded on the drone. So this is an example that where you can see this is a camera. Of course, we are going faster than in reality in the corridor of our university. And as you can see, the combination of SLAM algorithm, of single image depth estimation and semantic segmentation altogether allows really to close the loop in a very accurate way. So to have really a semantic 3D map of an indoor environment in a reliable way, as shown here. So what do you need to do now to do this? I mean, we discuss about a small onboard unit or streaming the data, but in any case, we don't have a workstation. We need to work in real time. So, I mean, discussion will be very long, but basically what you need to do is to optimize your process. Optimize your process, and luckily nowadays there are a lot of architecture or solution that can come to an help. So basically what we normally do is to customize the architecture of the network in order to reduce their processing time, or to do some so-called knowledge distillation to reduce basically the parameters of our network in order to make them as efficient as a larger one, but still able to be hosted on a small onboard unit in order to still be able to process this kind of information in real time on board or in remote, but still in real time. So what's next? Basically, my takeaway message is that there are a lot of applications where real time could be really useful in the future. So I think that this is something that we will see more often, more and more often in the future. There are a lot of UAV and that are nowadays available that can be connected or can be embedded in larger networks. Drones are getting basically a flying sensor of a larger network, and they can capture and provide information in real time every day more. And on the other hand, we have always better processing speed, lower latencies in the communication. So the technology around drones in general are supporting this process. Of course, if we look at the accuracy, we didn't have time to have a look at this. Of course, the accuracy that you can get in real time is not comparable to post-processing solutions, but still, this is sufficient for many applications. You don't need to reach a millimeter level every time. There are applications where this is enough to have a rough idea of the volume that you are investigating, such an example. And in this case, you can do that in real time. Yes, as I said, hardware and software components are improving very fast, and there will be new, and they will become the standard very, very soon. And I didn't discuss, but there are a lot of emerging solutions like drone in the box, tethered solution, combination of ground and terrestrial and aerial drones that will further boost this kind of real-time applications. So before concluding this presentation, I wanted to thank all the guys, the PhD and the postdoc who supported this work in these years. Yeah, to do a small advertisement what we are doing in our university, in the University of Twente, where we recently established a UAV center where we really aim to develop a new and innovative solution for quite a bunch of application close to geoinformation and geomatics. So this was yeah, just a very small and short overview of yeah, what is going on real time. Thank you for this opportunity, and if there are questions, I'm more than welcome to give an answer. Thank you.
Thank you, Francesco. Incredible the advance you get in your group. And I would like also to highlight the progress in photogrammetry, because when we deal with photogrammetry in the past, we always need post-processing, and now we are demonstrating that real-time is possible. Your presentation was the best example to demonstrate the real-time capabilities of photogrammetry, and for sure that the different applications, the different domains are incredible, and congratulations for these achievements. Okay, so regarding question, waiting for some question in the chat, I would like to ask you about when you present the semantic analysis using images. I was wondering if you take advantage of the semantic analysis in images in 2D, trying to extrapolate to 3D domain. I try to explain. If you apply some algorithms for the detection of objects in images using different architecture, as you were saying, optimizing the architecture, the parameters. If you apply photogrammetry, for sure that we can get a semantic analysis in 3D domain. I was wondering if you take advantage of this capability to connect, let's say, the artificial intelligence in 2D with the structure for motion and the new photogrammetry in 3D.
Yeah, very often the two things, especially when we use deep learning, are really combined. So such an example, we very often use multitask learning. So we have basically we learn two tasks at the same time, or we implement basically two tasks at the same time. So the single image depth estimation together with the semantic segmentation, and these two tasks help each other very often. So this helps the 3D reconstruction helps the semantic segmentation and vice versa. So if you have an object that is standing, this helps to segment this also correctly, and vice versa. If you have an object that you can detect from the semantic segmentation, then also this helps to segment in 3D this object in an accurate way. The two things are related. I mean, all these techniques look or behave like the human being. We combine the two things together. Geometry and semantics are in together, no, in our way to reason, no, and to perceive the external world. And basically they are mimicking, or we are trying to mimic in a way also this kind of understanding with this CNN algorithm, this deep learning algorithm, more than just CNN. Yeah.
Right. And last question or comment. We were doing a similar project related to those, let's say, detection of speed of vehicles. But in our case, the idea is to use cameras for avoiding collisions in roads with animals, okay? So the idea is to apply these, let's say, basic geometric principles that you were explaining, related with the angles, the distance, and the capability to estimate the speed. We are also applying some computer vision approaches because we realize that in some way, sometimes are faster than artificial intelligence. And we are assessing the speed, but also the trajectory, because depending on the trajectory, we can differentiate between animals, pedestrian, or cars. But the main problem that we are facing is sometimes the high level of false positives, and sometimes this is a problem.
this is always a problem. I mean, in the end, this algorithm work very well if they are trained with a training data set that, I mean, they are not able to generalize, or they are not 100% reliable still. So, I mean, technology is going there, improvement are evident, I guess, but still this is not 100% reliable. And still, if you train your network with one typology of data set and then you try to do something totally different, then for sure you will have still this problem. Yeah, that's still a limit. We are not totally there. We are working to go there, I would say.
Okay, thank you for the answers. Thank you for the feedback. I don't know if Pablo, do you want to ask something to Francesco?
I would like only one question, a summary, because in the last part of the presentation you talk about the accuracy. So only to have the numbers, okay? We know that it's not the same accuracy, but what are the terms of accuracy we are talking about? Some meters, decimeters, more or less, only to the figure.
You mean for an orthophoto, such an example?
For example,
the
yes.
orthophoto depends on the GPS you have on board. So, and then of course you can have some problem on the edges of the buildings. So if you generate an orthophoto, then don't expect the densification. I didn't discuss this, but when you densify a point cloud in real time, of course, the 3D reconstruction that you get is not as sharp in the edges, such an example, than what you get from a commercial solution or a classical semi-global approach. There are outliers, and they are still there. There are incomplete reconstruction or not accurate reconstruction, and they are still there. And in the ortho rectification, you will see this. So this is more for quick mapping. So if you need to have an overview of the area, then they are good enough. If you need to do something more, then it's very complex. Yeah, in that case, real time is not comparable. So talking about accuracy, for the geolocalization, this is mainly due to the GPS, the GNSS you are using, plus some inaccurate 3D reconstruction. So the point cloud is something that is a little bit more than what you will get from tie points. It's densified, but still you can have a problem on the edges. You can have outlier that generate some weird 3D reconstruction here and there. So, and then of course, I wouldn't measure from this really the millimeter, for sure not. Decimeter, I would say. Yeah.
Okay, thank you, Francesco. In relation to the question that is for the assistance, there is only one question, but it's not but it's related to another topic, that is why is an airport private drone in luggage? So it's due to the transporting the lithium-ion batteries. So it's not related.
This is not. They can, I guess, but there are some limitation. I think depends.
Yes.
Mainly
I am answers also about the batteries. Usually some the problems. So to transport the batteries.
Yes, I must say for the batteries that if you have onboard unit, the batteries don't last forever. But luckily, the lithium batteries are improving with a rate of 3-5% per year on average. I read somewhere. So also that aspect is getting better and better. Such an example, we use the onboard unit is better on fixed wing because they fly more than 1 hour typically. So the amount of energy that you use for the onboard unit is small compared to the flight time. If you use a rotor drone, then of course with an onboard unit you reduce quite a lot the flight time of the drone. But okay, this is the only thing that I can say about batteries and real time.
Okay, thank you, Francesco. Nothing for my part. Diego, I don't know if Maya wants something to add.
Okay, thank you, Pablo. Thank you, Francesco, for the feedback.
Thank you.
I don't know. Maya, do you have any comment or question?
No, nothing from me. I think we can move on further.
Okay. Okay,
Thank
so
you.
we can move to the next speaker. So thank you again, Francesco, and congratulations for your research and your group.
Thank you.
Okay, let's say our next speaker is Katerina Margariti. I am going to read directly the most important thing about Katerina. It's a CEO of Xeligent, that is a company related with drones. She received her diploma in physics from the University of Athens and the master degree in telecommunication system from the same university. Currently, Katerina is doing the PhD in the Department of Informatics and Telematics in the University of Athens in the field of optical system. He has more than 10 years of professional experience in the ICT sector, serving in several positions concerned with technology and product development. Katerina has also acted as a quality and information security manager in several companies in the past, and she has experience from participating in numerous European projects and national funded research projects, as well as national and international government tenders. She has also served as Horizon 2020 project manager and project coordinator, and she has also coordinated all actions concerned with the submission of Horizon 2020 research proposal. She is co-author of 6 peer-reviewed journals and conference proceedings. So Katerina, thank you a lot for staying with us and for sharing with us your expertise at front of your company and the expertise related with drones manufacturing.
Thank you very much for the invitation, for giving me the opportunity to present this very interesting event. So I am here today with Dimitris Perikleous. He is our senior aeronautical engineer and responsible, let's say, for the development of this very novel reconfigurable UAV for agricultural and not only applications that we are going to present today. Our presentation in relation to Francesco will be much more focused, as I consider my company more hardware-oriented than application-oriented or software-oriented, though we are also developing software as well. So I'm representing Xeligent and LANCETT. I am the director of the manufacturing branch that is in Athens, Greece. However, Xeligent is a Cypriot company. So in relation to what we are going to present today, I would like to say a few words about Xeligent, my company. Also this very interesting UAV, reconfigurable UAV that we are going to design and develop is, let's say, the outcome of one of our Horizon Europe program, that it is the Chameleon project. So I would like also to devote 2 or 3 slides specifically to Chameleon project, and then present the solution of the Pulsar prototype. So Xeligent, as I said from the beginning, is a company that is hardware oriented. It specializes on the design and manufacturing of UAV. It is custom, basically, UAV, depending on the application. Besides that, we are, let's say, a research oriented company. We have been established around 3 years ago. Starting with 3 Horizon 2020 projects, focusing on UAVs, of course, on the design and manufacturing of UAVs for different applications. Our starting projects were dedicated to security applications. However, it seems that the agricultural, environmental, livestock seems to be an area that it is of high interest to us as well. We have been established, as I said, 3 years ago in Cyprus. Around 1 year from the Cypriot company establishment, we have created our manufacturing branch here in Athens. And almost 1 year later, we have also established a subsidiary in London, UK. So this is more or less the presence of our, let's say, small company, because we are a small company. We are currently having 30 employees. So as said, we are designing and manufacturing our own UAVs. So we are presenting here, let's say, the prototypes that we are having, that we have currently developed. We may say that these are medium-sized UAVs. So with the highest payload, we have the Kerberos UAV. We have a tethered UAV. We have said that it was the first prototype that we have created. We have dummy that we are using mostly for testing purposes, and it is a wholly 3D printed small UAV. And we are currently on the progress of finalizing, let's say, the development of the Optra prototype, that it is a fixed wing with VTOL capabilities. So as said, the main focus of today's presentation is the presentation of a novel reconfigurable UAV that we have envisioned under Chameleon project. So Chameleon project is a project that has been funded from under Horizon Europe framework. It has a starting day. It is basically a new project. It has a starting day July 2022. It is a 3-year project with a total budget of 6 million. It happens that specifically for the Chameleon project, Axelgens is also the coordinating entity for the specific project as well. So in general, Chameleon, it not only focuses, let's say, on UAV, on novel applications that are UAV assisted, UAV aided for agriculture, livestock, environment, forestry, etc. This is part, of course, of the Chameleon solution. However, Chameleon provides, let's say, a digital infrastructure that embraces, let's say, these different applications. And it is also, let's say, a collaborative space where the different stakeholders may exchange information, may exchange data, knowledge, but also may exchange digital products. So this is, let's say, the main focus, the vision of Chameleon project. Chameleon project that, of course, it has as part of its let's say, focus, the development of novel UAV applications for agriculture, for livestock, for forestry, etc. The technologies that are going to be developed, it will be tested in 3 different countries that involve Greece, Spain, and Austria. Now, I'm moving onwards to this Pulsar prototype. As I said, we have envisioned under Chameleon project the design and development of a highly reconfigurable UAV, that it is a UAV that it is able, let's say, to change its size and configuration depending on the application that this UAV needs to serve. So the initial prototype will be produced as part of the Chameleon project, and in order, let's say, to cover the requirements of the Chameleon project. However, the specific UAV, the actual, let's say, potential of this UAV will be further expanded, and also my company also plans, let's say, to apply for a patent. So basically, the information that we can share in relation to this specific, it might be some kind of limit. So in relation to the supported configurations, and of course, in relation always to Chameleon project, the supported configurations, it is a quadrotor, octarotor, octarotor coaxial. So I will prefer that I will give the floor, because Dimitris is a specialist and he's responsible for the development of this novel, let's say, UAV, to provide some more technical information. Dimitris, can you please also appear?
Katerina, if Dimitris is not in the panelist list, it's not possible.
It is not possible. Okay.
Yeah,
Then
yeah.
okay,
Yeah.
I will try to provide this information as better as I can. So the specific chameleon drone has 8 telescopic arms that are expandable, let's say. So with this capability, we may provide the change in the sizing of the UAV. So combining this telescopic arm by 2 through, let's say, we can, and providing, let's say, the maybe, sorry for that. So we have, as I said, we have 8 telescopic arms that can be adapted to have both 4 or 8 rotors and an option for 2 engines on each arm. All parts will be permanently mounted on the vehicle except the motors and the propellers. The operator will be able to connect the motor with a proper propeller to the drone through a simple, quick and secure plug-and-play procedure. The arms will be able to fold in order to make transportation easier. Also, we have envisioned built-in sensors that may detect the modifications in the drone configuration and automatically adjust the flight controller software. Also, the sensor will serve as a checking, let's say, a control mechanism in order to ensure that we have the proper installation of the parts and in order to minimize human error. So this is more or less the configuration of the UAV, the different configurations of the UAV and how this can be developed. As I said, of the Chameleon project and the different optional payloads that we can adapt to the reconfigurable UAV. So, as part of the Chameleon project, and in order to serve the different, let's say, applications of the Chameleon project, the different, let's say, sensor and mechanisms that are going to be onboarded are a FLIR Duo Pro, a MicaSense, of course, NVIDIA Jetson, a spraying system, an RGB sensor, or a LiDAR sensor. So this is more or less. I don't know if you would like to add to ask something.
Thank you, Katerina, for the presentation and for congratulations for the company. It's not easy at all to get this number of employees. We know perfectly with our spin-off, and so congratulations for this this number and for sure for the novel designs you presented with the different reconfigurable solutions and for these hardware-oriented, let's say, drones that are really interesting and for sure that are provide very useful solutions. I was wondering about other type of applications you have in mind, especially in the company, for the next months, the next, let's say, the medium future. Can you?
As part of our goals. In general, I must say that for the outdoor applications, there is a range of applications that we have covered. So the next step for us will be either to proceed with high payload UAVs for outdoor applications, and for sure the indoor applications is next step for us, the next step for us. So in general, considering yes, the outdoor applications, and given that we are currently participating in, of course, we are at the stage of the prototype. We haven't produced yet a commercial product. This is within our, let's say, plans as well. However, in relation to the outdoor applications, research-wise, and in the TRL7, let's say, level, we may consider that we have covered a wide range of applications, from security to agriculture, to environment, to forestry.
Okay, and what about the terrestrial domain? Do you consider to increase your branch towards this domain or not? Because sometimes everybody talks about aerial drones, but sometimes terrestrial drones can provide added value in some applications.
Okay, in general, Diego has said we are a company of 30 persons in total. We have managed to expand very, very quickly within three years. We need to consider our next steps very, very carefully. For sure, for the time being, we are focusing on the current prototypes and the certifications needed in order to have a commercial product. And immediately after, we will examine all possibilities. But for sure, we have identified a gap in relation to the indoor vehicles. So all other, let's say, application areas are of interest, but we need to take into account that we are a small company and we need to consider our steps very, very carefully.
Yeah, totally agree, Katerina. Pablo, do you have any question for Katerina?
No, I have no any question. I'm checking the chat and there is no questions from the assistants.
Okay, so Maya, we can move to the next speaker if you want.
Yes, we can move.
Okay, so thank you again, Katerina, and congratulations for your advance and your progress. Okay, so our last speaker in this webinar is Xavier Silva Garcia. He's CEO and co-founder of EMAP. He's aeronautical engineer. And EMAP is a company focused on drones, providing services with drones, especially in agriculture. So with technical background in aeronautics, Xavier, and in artificial intelligence and remote sensing application, he is the main responsible in business development of the company. He has led this industry line for the scientific area to a network of 35 operational and commercial centers in 22 different countries over the world. EMAP is an agrotech and artificial intelligence company who offers a digital monitoring and forecasting through their layers platforms. So we had the opportunity to test this platform. It's great. I think that it could be nice, Xavier, if you can share with us and with the audience all the achievements that you get with the company, and especially these layers platforms. Are you ready, Xavier?
Yeah. So thanks, Diego, to the invitation from this webinar. So we are pleased to be here. So yes, from my side, what we are going to explain today is this overview about the yield forecasting through AI models using one of the data that we are using today is the drone technology. So basically what I want to make a global overview is about if it's possible to take profit from the agri data that today is available in the market, that there's a lot of information. And basically to answer that, I want to explain you how we are managing the AI technology to generate quality and predictive yield forecasts. And also I'm going to introduce some use case examples. So what this sector today, the agriculture sector, is how they are using this kind of data or forecast in a real way. I'm not going to explain about EMAP, but about layers. Or it was not my focus at the beginning, but only to give some achievements. So today we made 10 years of history. We start with drones technology. So at the beginning, we was drone hardware providers, but really at the beginning we changed our focus to the data, and we create and we develop layers. That is our digital platform. And today we are working in 22 different countries, really focus and only focus 100% on agricultural sector, with more than 2.5 million hectares today subscribed on the system. And really focus on what I'm going to explain to you, that these forecast models to help our farmers, growers, traders, factories, so everybody that is involved on the agriculture sector and needs this yield information. So first of all, I want to go to the data that today is available. So to explain which kind of information is available on the market and the growers and the factories are used to work with, and how we are using this data, we are giving this forecast. So first of all, going to the data, one thing that is completely true is that there are massive data on the market. So there are too much information. So the growers and the industry and the factories, they have information from satellites. So they have different constellations with different sensors. They could apply also drone technology to capture data with more high resolution information from my side, more focus on the detail of units. They have information, public information that is related with soils. There are a lot of information about weather, about climate. They have their own weather stations and also global providers. There are sensor solutions related with water, with irrigation, related with the machinery. There are a lot of information about sampling. So they make soil samples, they make leaf samples, they make biometries to get information from the leaves and from the soil. There are a lot of different applications related with nodes, with plagues, so to collect data from the field. And for sure, at the end, most of them, they have ERP systems, so global systems to manage the information, or maybe Excel sheets to manage all the historical information and the current information. And at the end, this is a lot of information, a lot of indirect data. There are a lot of different platforms, viewer platforms of this information. A lot of times there are few integration and few connection between different databases. So what happens at the end is that the final user, even if we're talking about grower, about the factory, about the trader, about the insurance company, for them it's difficult to take decisions because there's no a final answer of what they are looking for. To go through this, before to go how we could improve that and how we could give them a better solution or solution that fits on what they are looking for, I want to explain and go more into detail on the different information that is available. So first of all, I'm going through the satellite information. So today there's a lot of different constellations available with different sensors, the optical or visual ones, multispectral, radar, thermal. So we have the Sentinel 1, 2, 3, I think 4 also, that is ready. We have different Landsats. I think that the last one is the 9. We have Planet, we have Player. So we have a lot of different satellites constellations that provide information. Depending on what we want to look, it's more useful to use one sensor or the other. But at the end, we have this summary that how we relate this information to a practical way. So at the end, from our perspective, the satellite information at the end give some information, but we need to consider with two characteristics. So first of all, the information from satellites are in meters resolution. So at the end, it's useful to make zone analytics, zone maps. And they have a really nice achievement and practical use, that is that they have a huge frequency. So at the end, they are really useful to make monitoring tasks. And at the end, the information that we take off from these sensors, from these satellite sensors, are related once with the vegetation index, so related with health, so we can make multispectral maps. Also, if we are using another sensors like radar, they are more related on the physical, so we could measure plant size. And if we are talking more about the thermal sensors, we could take over the temperature about the leaf, about the plant, so we could make a thermal map that are related with the water needs. So basically, with this information, as I mentioned, when we go to the agriculture application, we could use it in one of the nice things is that we have different, we have a lot of frequencies. So once a week, twice a week, or once every day, if we have some of the constellations, we have information, but we are going to analyze everything in zones. So we cannot count plants or detect plants because we don't have enough resolution. But if we are talking about zones, global view, this monitoring, they are super interesting too. So this is one of the use case for that. Then if we talk about drone, the same about the satellites. So depends on the sensor, it's going to be more useful or less for one application or the other. Normally, they are the sensors that we applied in agriculture are more optical, visual, multispectral, thermal. It happens the same from the satellite part. So with the multispectral sensors, we are more focused on the vegetation index with related with health, biomass. If we talk about visual cameras, we are more focused about the plants counting and units detecting. So this is really nice. And then if we go to the thermal sensors, if you apply it on that, we are going to look in the temperature. What it is interesting with drones is that as we have a really huge accuracy and resolution, sorry, at the end we are talking about centimeters. So we are used to working with 1-2 centimeters per pixel, and it's really nice to make plan maps. So we are going to go to the units. So if we want to know the number of lettuce that you have in 1 hectare, that is around 60,000 units. It's important that you need to use drones imagery, because with satellites it's impossible to achieve that. But if you want to know about which are the different zones you have on a field to make different treatments, maybe with the satellite information is enough. So basically, the drone is really nice if you want to count units to go to this resolution, and at the end you need a operational requirement. So it's more for a high resolution verification than from monitoring perspective. With this information at the end, the nice thing is, as if we compare against the satellite ones, as I mentioned, you have really high accuracy, so you could detect plant by plant. So in this case, for example, this is a use case in sugar cane. In this case, what we are giving is the plant gaps analysis. So we detect where are gaps to give them then this information to pay exactly the new plants that it's required. So they know exactly if they need 100 units or 1,000 units, and also to be more efficient on the replant treatment. And the other thing is that, as I mentioned, this every time that you need that, you need to make an operation. So it's once, twice, third by a season. Going further, so another information that is available on the market, a lot of information about climate, so about weather. There are global providers, and also if they have information from weather stations, also they have their own information by zone or by field levels. Really important, because at the end in the agriculture, this is one of the most relevant parameters that you are based on. So if it's raining or not, if it's cold or not, if you have enough radiation, it's something completely important to understand how is the yield behavior. Also, if we talk about agriculture, another parameter that's so important is about soil, for example, soil maps. So a lot of times the governments have and the institutes provide these soil analytics about huge regions. Also, in agriculture, there are information about sensors. They are so important when we are talking about water, for example, from the irrigation, to understand how is the soil and how is the leaf. But also, there are a lot of sensors in the machinery. So you have real-time tractors tracking or information about what is happening with the tractor treatments. Also, talking about samples, there are a lot of analytics on fields. So they are making soil samples, they are making leaf samples. And also, if we are talking about the APP, so as I mentioned, they they have different tools to take notes, to take photos for alerts, to apply new treatments about plagues, wherever. And finally, most of the times also this sector, they have ERP systems, so they have this historical data, agronomical data that are related with the boundaries, with the crop, the variety, the productions, about start date and end date, the costs by field, by treatment. So at the end, all this information also normally is available for the sector. What happens at the end? That there are a lot of different information, and it's difficult, as I mentioned before, to take decisions. So where I need to look and which is the treatment and the action that it's needed. The goodness about the forecasting models, the AI is at the end that we could use all this information to simplify this decision taking and giving them exactly the answer to their needs. That in our case is this yield forecast. From our point of view, the most relevant information that is on the field is the yield information. Everything that is happening on field is related on this yield. So I'm going to put more water or less, more fertilizer or less. What is going to happen? It's always related with which is going to be the yield at the end of the season. So what we are doing here this is an example of database. And so per each plot, we have a lot of information related with this agronomical information. So which is the boundaries, which is the crop, the variety, the relation type, the latitude, the longitude of the plot, which is a lot of different parameters, and for sure, which is the production of these fields or the quality. Then we have information from drone side. So if we have drone information, not always it's needed, but if you have it, it's nice to put in the models. We could have different bounds of the sensor that you are going to put. The spectral index. Also, if in our case we are counting the number of plants. If we talk about satellite information, we are using different satellite information, multispectral and radar one to take different information about the reflection of the light from the plants, from the leaves, and we could analyze different aspects as the water stress, the health, the photosynthetic health, different aspects. And also we are using the climate information, the weather information in a daily basis about temperature, maximum temperature, average temperature, minimum temperature, which is the precipitation, the wind speed, a lot of different parameters. So at the end, we have a lot of indirect data. And as I explained, at the end, the final user needs to simplify to understand all this information in a more useful way, and that is the goodness of the AI that helps us to combine all this information in something useful. So it is possible, yes. So basically, what we are doing is that we are collecting all this information. We are creating these databases per plot, and we are combining all this information to answer the final question, that is, which is the yield in terms of production and in terms of quality. So going to this point, so how we manage these models. Basically, what we are doing is first making a data integration. So we need to connect with the satellite information, connect with the weather information, connect with information, agronomical information of the user, with their weather stations, with their samplings, so whatever they have. And with this information, once it's integrated, then we need to generate an historical series of data. So we need to generate the historical the database about the last 4 years of satellite information from weather, from the historicals. Then we need to go to a data quality process. We need to filter which data is okay, is not okay, which are the outliers. And finally, go into the data modeling. In our case, we are using a neural network to apply that. Here, it's not my purpose, but we go from the most simple validation model, from a random forest application to the neural network. But at the end, what we are doing is we are creating models using the historical data and the real data to validate. And thanks to that, at the end, we achieve a model. So to understand the amount of data that we are using and the unused data that the sector this data that is available, you could see here, for example, that from each plot, so from each field, we are making, we have more than 150,000 hectares, 15,000 descriptors per plot. So we have because at the end, we have these descriptors from the last 3-4 seasons. So there's a lot of data only per taking into account one plot. So imagine every plot. And with that, what we are doing and what is possible to do today is make a data correlation to understand which are the parameters, the descriptors that are more related and are more interested to look for, how they are correlated with the yield production and the yield and quality. This is at the end what we are more used to do. With that, we make these correlation graphics, and the result of what I'm explaining is a forecast model that explains the production behavior. This, for example, this is for sugar beet. This is a user model that explains how is the behavior of the production over the season, or also the polarization or the sucrose evolution. So we are creating this specific model that describes which is the production in terms of yield and quality. And it's really interesting to understand that thanks to these AI models that combines all this information, we could achieve a really nice correlation. This, for example, this is an example of an easy model with only 181 samples. This is a really basic ones. Normally, we are used to work with more than 1,000 samples, not only 100. But what is interesting here is that we could see the correlation against, if we are only making this correlation with every single descriptor, we could see that the production correlated with MDPI, with the average, is only 0.24. Or if we go to the humidity, is 0.43, or with the wind speed, that is a huge correlation, it's 0.48, or the accumulating of temperature, it's 0.28. So at the end, we could achieve a nice model that describes better the final output, that is production or yield terms, thanks to this combination of descriptors. With that, at the end, I want to go directly. What we are making and what we are achieving is that in a feed by feed basis, we are making a description about which is the quantity of tons per hectare that they have in each month of the season, and which is the forecast. And thanks to that, also we could determine which parameter, which descriptors are more have more impact or less impact. So going to the final applications, thanks to that, what we are doing. So we could provide information, for example, about the potential production for new areas. So, for example, if you are you want to add a new area and you want to know if it has sense to buy or not, or you have to apply new insurance and you need to calculate the risk, or you have to buy as a supplier, you need to buy crop. With this tool, you could understand before to pay which is the most suitable and better plots to buy. Also, we could work, and we are used to work with the corporate companies to make the annual forecast, because we are providing this yield forecasting. We are supporting the financials cost. So at the end, thanks to our accuracy, in this case, for example, this user of 5,000 hectares, they have an accuracy of 99% thanks to our system. We are supporting the logistics. So thanks to us, they understand which crops, which fields they could harvest sooner or later to achieve the goals of the factory. They could use our system to understand which are the best hybrids or varieties to put in each zone. Or talking about the sowing, so about the replants, they could understand which are, in this case, the gaps of the fields, and to understand if they are making an improvement on production thanks to that. Thanks for your time. But at the end, this is a reality. So thanks to this technology, we could use all the data that is available, and we could answer to the most important question of agriculture sector, that is, which is the yield in terms of quality and production.
Thank you, Xavier, so much. Congratulations for the company for let's say, be close to the farmer. That is so complex in agriculture. So congratulations for different reasons. First of all, because it's really difficult try to, let's say, to advance in some specific fields. One of them is agriculture, and you provide a solution that is a real solution, because it is not only to deal with drones, with satellite, with big data. It's also the capability to analyze everything and to provide not only a solution, a didactical solution to the end user. And this is not easy at all. to provide a final report, as you were saying, to take decisions. And sometimes the farmer are waiting for that. And this is really important. I would like to say congratulations for that. My questions are related when you're talking about the data integration that are crucial in your business model. I was wondering about the way you are integrating data heterogeneous that are coming from satellite, that are coming from drones, that belongs to different spatial resolution, but also spectral resolution. How are you dealing with that?
Yeah, this is the key, one of the key activities that we made. So preparing all the infrastructure to be able to work with models by user and to collect plot by plot, field by field, all the data that is available. So we have a database per user, data map for them, and we collect all this information and we traduce in a way that we could use in the models. So normally we have an average per plot, and this is, well, it was really complex to achieve that, because at the end, when you have connected with satellite information, all the provided similar. When you go to the weather, always more or less it's similar. But when you go to deep on the users' ERP systems and different economical databases, everyone is different. So you need to make a huge effort to connect with their system. So normally we spend 1 month on making this integration. We have a CPM manager that goes on home of our users to connect, to understand better, understand how is their databases, and to connect on that, because this is crucial, because we need the data always updated, because every time that they are making harvest or they have a new information, it's important to apply on the models, because they are going to take a solution and an action related on that. So for sure.
And I guess the solution you are offering for data integration to the end user is based totally on the cloud, right? Because otherwise, end user has no the infrastructure to processing and to deal with all big data. Eh?
Everything is on cloud, yeah, for sure. And also, I forget the drone one, but as we start with the drone imagery, at the beginning it was prepared to the drone information, and it was nice because drone is so heavy, the data that you need to store, that going then to the satellite, to the weather, to the other information was easy, because it's not so tough as working with drone information that at the end is massive, because you have a lot of resolution, you have a lot of photos per field. So yeah.
Yeah, another important point you mentioned is the importance of the field data. I totally agree with you that if you don't have in agriculture data coming from the field, you know, the forecasting and everything is going to be sometimes very, very far from the reality. I was wondering if MAF provide this IoT solution or not as within your business model.
For sure. So from our point of view, the field data is the basics of everything. So if you don't have field data, you are not going to have a good model. So that's why at the beginning, normally this corporate, we are really focused on used to work with B2B. So we are working with corporate users. Normally they have historical information, and with this historical information, we could start with the models and not start from zero. But if there's no historical information at the end, we are starting from zero for this specific user. You cannot expect to have a huge accuracy model of the yield forecasting if you don't have historical data to train something, because the global data in agriculture or from our side, I think that it has no sense, because there are so many parameters that affects on the yield production, so many variables that it has no sense to try to apply a global solution to this specific problem that it's so complex.
But as a MAF company, you provide the end user with these IoT sensors, or the end user has to acquire with another company?
They are open to buy everything, whatever they need, but sometimes to start, it's not necessary to have sensors. So what is important is to have the boundaries of the fields, and related with these boundaries, the information about the crop, the variety, start date, end date, the yield production, and the quality production, that normally is something that they already have from the last 4 or 5 years. So with that, we could start to make everything. It's not necessary to have the IoT sensor if you have the reality of what happens on that field. If you don't have this information, for sure that it's really difficult.
Yeah. A last question. From our expertise in agriculture, it is clear that geospatial technology provides a good insight, considering the resolution, the spectral capabilities of the different sensors and platforms. But according with our expertise, one unknown part of the agriculture is the subsoil. The subsoil is crucial in agriculture, especially the width of 1 meter below the ground, because inside are the nutrients, are the main properties for having a good yield. And sometimes the main problem that the farmer has to face is that there is no specific or let's say easy to apply method that can assess the quality of the subsoil. I was wondering if EMAF is considering this alternative as a solution.
We have one of our license of one of our products is called Soil Tech, that it's just related on this issue, that what we are giving them is where is the minimum points of sampling that they need to take to make a soil analysis. And then with this soil analytics that they need to do, we are combining with such information to make a more accurate global map of soil. And one thing that I want also to summary here, that the drone information is really, really important, but depends on the use case. So if the crop needs units and descriptors, so you need to know the quantity of plants you have on your field, on your plot, drone is the only solution. And this is, for example, for lettuce, for trees, this is important because normally they apply fertilizers by units, so they need to know that. Or for the harvest from the logistics, as they are expensive, they need to have these numbers. But if it's not, maybe drone is not suitable for this kind of crop, because at the end you have an operational process and cost that is related. But for example, if you need to count, the drone is something completely necessary.
Okay. Thank you, Xavier, for your feedback and for the answers. I want to say, Pablo, something from your side?
Yes, we have two questions from the chat. Xavier, the first one is, what GIS do you use it to did the system?
Sorry, again?
What GIS software did you use to implement the software, or what? How?
No, we have our own GIS, so we have our own platform, but it's called Layers. So it's a proprietary platform.
It's working in about some framework, or what language, or what?
Everything in Python, but you could download everything that we made, all the maps that we made. You could download in different formats and files, and after that you could work with QGIS, with ArcGIS, whatever they had. So
okay, perfect. And the second question is, if you could please give some recommendation for drones analyzing light absorption for plants.
Yeah. At the end, today there are a lot of options, drone options. So from this visual, so to counting, the only thing that we need is a good sensor, optical sensor. We are looking a lot of Phantom 4 LTK. Is one of the most common drones that we are looking in the market. So I think 60–70% of the market is working with that with our platform, and it's working really well. So from my side, it's the one that I saw most in the market.
Okay, thank you, Xavier. And Diego, if possible, we have a question from Francesco. is what about the 3D reconstruction image from nighttime image? You are testing this, or you have some problems about this?
Yes, this is a good question for indoor mapping, because typically illumination in indoor environment is something, especially if you enter in a building that is affected by an earthquake, you don't have lights inside. So what we did, and I didn't show today, was to develop a network that can basically try to restore the illumination or improve the illumination. Typically, in that case, the drone has a light on the top, so it's a very regular illumination. In this case, the problem is that the classical photogrammetry has problem to work, because when the drone is moving, also the illumination of the object change, because together with the drone, also the light and illumination moves in the indoor environment. So in this case, a single image depth estimation can be a good support in order to have a 3D reconstruction of the environment. And other than this, for the segmentation, we have a network that try to restore the illumination. So it's a sort of, to try to improve what you can see from the RGB image, and then try to segment and to classify the scene in this way. So we have, if they search, a publication on that. Again, this is something that you try to do. Of course, this is a quite extreme condition, so this is not always possible to get a perfect result. But still, we noticed that in most of the cases it was sufficient. It was good enough.
Okay, thank you, Francesco. So Diego, we have no more question in the chat. We are in time, so I don't know if there's any question, or we can.
Okay, thank you, Pablo. From my side, there is no difficult questions. I only want to say thank you to our speaker. It was a privilege to have a recognized member from the industry, but also from the academic background. I think that the webinar was great because it combines real-time application, very innovative and novel solutions for real-time application coming from Francesco. Then Katerina present to us very novel solutions from the hardware side, combining different multi-rotor and multimodal solutions in drones, aerial drones. And last but not least, Xavier present a clear and vertical solution for agriculture. As I was saying, it's not trivial at all to be close to the farmer and to provide a solution very useful and in a didactical way. I think that a map gets success with the Layers platform, and the proof is they are opening market outside Spain in different countries, and this is for sure very successful. So from my side, thank you to all, especially for the speakers and also for the audience. It was a pleasure to present today this webinar, focus on different solutions for drones. And I hope you can take advantage of this knowledge. And for sure, we are going to share the link of the meeting with you. And yeah, this is all from my side. Thank you all and have a good day.
Thank you. I would like to thank the chair and the speakers for your time and these interesting contributions. Also, thank you to our attendees, and I hope you found this webinar interesting. And as a reminder, the recording of this webinar will be made available online at the journal's news and events page. And that is it from me. I wish everyone a nice day, morning or evening, wherever you are, and hope I see you soon. Bye-bye.
Bye.
Thank you very much. Bye.
Bye.
Bye.